Hey guys, and welcome back to my channel, and this is a follow-up and closing of the loop on this 120 volt isolation transformer. On Amazon, it is the model AFT-1000W. The specific topic I wanted to cover that I had reached out to the manufacturer, and the manufacturer has been absolutely awesome, so thank you to them over in China. So initially they had sent me over an updated program hex file to reflash the microcontroller that runs all the advanced features such as the overvoltage and undervoltage protection, and they said that it was programmed to the proper set points, which I requested 132 volts on the overvoltage and 105 volts on the low voltage. However, when I got into looking in for a programming tool, I just didn't have a lot of luck, and what they were able to do is they sold me this new updated control board. This is actually the old one, and they basically reprogrammed that chip right there, the U1, with the proper voltage set points. So instead of 145 and 35 volts, it is now at the 132 and 105. And this is for, with my Variac, I'm just going to go zoom out here a little bit. So we're at 122. And if we bring it down to 105 volts, you should hear the relays click. So it shuts down right at 105 volts, which is exactly what I want it to do. Now we'll bring this back up, and it will not re-engage until the voltage is back into a safe range. And finally, on the overvoltage protection, once this hits 132, it should shut down too. And there you go. Now, it's going to blink like that. You're going to see that it is going to continue to blink. You'll see the protect continue. But then once the voltage gets back into a safe range, the microcontroller should go and re-engage the relay to the output outlets in the back. I'm very happy now with the functionality because it is now working as described and advertised. Now, to be fair, the 145 and 35 volts is considered voltage regulation, although it's not really effective in my opinion. The 132 and 105, as I mentioned, is a lot more reasonable because that's usually the upper and lower limits for any device that's only set to work at 120 volts. Now, the last feature I wanted to touch upon that I wasn't able to really go into too much depth in the first video was the thermal protection. This microcontroller is also monitoring the temperature of the transformer inside so that if it gets too hot, it will also shut itself down. And I was able to find out from the manufacturer that it is a Class F, as in Frank, designed toroidal transformer, which means that if you were to look that up, that's 150 degrees Celsius is the maximum temperature for those coils to be operating before they start to see any kind of failure. Now, I was not able, when I asked the question, I was not able to get the exact temperature at which this microcontroller will shut down the output due to thermal issues, but I would wager a guess that it's probably going to be somewhere far before that 150 degrees Celsius. And at that point, if you're heating up that transformer that hot or even getting close to it being that hot, yeah, you're probably not using this device correctly. But it's good to know that it has thermal protection as well as the voltage protection. I did get a question on the first video, and this goes out to James Condon, and the question he asked was, hey, this is a cool device. Would it go and filter out high total harmonic distortion on a portable generator? And unfortunately, no. It would not suppress enough of that high total harmonic distortion enough to make a difference in the loads that you're powering. It does have some filtering components in the back, some inductors and some capacitors, fairly small, and those are meant to suppress EMI, RFI, so we're talking much higher frequencies, say in the megahertz range and the kilohertz range, that you would normally hear buzzing or anything like that through speakers, for example. This has those suppression components inside. That is meant for the higher frequencies. Now, lower frequencies, so 60 hertz is what we want. We want 60 hertz to go in, we want 60 hertz to come out, but you also have to deal with the harmonic distortion, so the harmonics of 60 hertz, so 120, double that, 240, so on and so forth. Those are the frequencies that we don't want. And the slower the frequency, the bigger the transformer needs to be, or in this case, an inductor, which is essentially acting in the same manner. An inductor or transformer, they store energy in its magnetic field. The slower the frequency, the larger the relative size of those inductor components need to be in order to suppress those lower frequencies, to correct and suppress total harmonic distortion. We're talking devices called load and line reactors, very large inductors that are extremely heavy, extremely expensive, and that just is not practical at the portable generator level. I apologize in the last segment if that got too technical, but overall, back to the matter at hand, I'm very happy with the result of the updated logic board for this device. I hope this information helps if you're looking to purchase a device like this. It is definitely a lot more feature-laden than most basic isolation transformers, but thanks again for watching and supporting the channel. I'll see you guys next time.